Today we're going to be looking at the lab write-up of the baking soda stoichiometry lab, page 13 in the chapter 12 packet for Chem 1. Let's review what you did with your lab. You had 3 different weighings during this lab. The first weighing you did was the plain old crucible by itself. The next weighing you did was the crucible with the baking soda, which was the NaHCO3, which is called also sodium bicarbonate. And then you heated this up. When you heated it up, you ended up with just sodium carbonate in the crucible. So this solid was sodium carbonate, which was a decomposition reaction because you formed 2 gases that escaped. You formed CO2 gas and H2O gas. Because of that, the mass went down. Again, because it was a decomposition. So the decomposition led to sodium carbonate giving off water and carbon dioxide, which you can see at the bottom of the page. Sodium bicarbonate, baking soda, goes to sodium carbonate, CO2, and H2O. So let's take a look at some data. I'm going to make up my own data here. Let's suppose that the crucible weighed 16.820 at the beginning. And then when you put the baking soda in it, it weighed 18.140 grams. And then ultimately, after heating and cooling, weighed 17.570 grams. So the first thing we want to do is find the mass of the baking soda that you used in the experiment. So you could see that the baking soda was in the crucible before heating. So if you simply subtract the crucible from the crucible plus baking soda, you'll get just the baking soda. So make sure you show your work. I'm going to do a subtraction here. So mine's going to be 18.140 grams minus 16.820 grams. And the answer to that should come out to be 1.320 grams. So I have 1.320 grams of baking soda in my crucible. Then we're going to find the experimental amount of Na2CO3 that we formed. So when you look at these diagrams, you'll notice that the Na2CO3, sodium carbonate, is in the final weighing. So if you simply subtract the empty crucible from the final weighing, you'll get just the sodium carbonate. So with my data, I'm going to take 17.570 grams minus 16.820 grams, and my answer is going to come out to be 0.750 grams. So that's how much Na2CO3 I have, 0.750 grams. And again, that's my experimental. Now we're going to find out, well, how much was I supposed to get in this lab? What should have been the theoretical? So in order to do that, we're going to use the balanced equation. So the first thing you need to do is balance it. So there should be a 2 right here, and everything else will be balanced. You want to put a triangle over the arrow to show that you had to heat this up to make it work, to make it react. And you're going to write down your initial amount of baking soda, which again was 1.320 in my example. That's how much baking soda with which I started. Now I want to figure out how much should be at the end. How much Na2CO3 should I have formed, understanding that this gas will not be measurable and this gas will not be measurable. So whenever you answer the question how much, we're doing stoichiometry as we've been learning in this chapter. This is going to be the big bridge for grams. So you have to add up from the periodic table the sodium bicarbonate, add up the Na2CO3, sodium carbonate, and you get 106. And now we're going to do the big bridge. So 1.320 divided by 2 divided by 84 times 106 times 1. And my answer here is going to be 0.833. So I was supposed to get 0.833. So this is the theoretical. Theoretical is what should I have made. What was I supposed to make? And the bridge is always going to give you that answer. So now when you want to figure out the percent yield, you just take your experimental divided by your theoretical. So my experimental, what I got in my lab was 7.50 grams of, again, the Na2CO3. I was supposed to make 0.833 grams, theoretically, times 100. And my results will give me 90.1% yield. And this is how you would find the percent yield in your lab.